objective was at 75.237 seconds. The initial path of the crew cabin from the vapor cloud carried it across the path of an adjacent contrail, clearly revealing its truncated form and attitude. The left wing became visible at 78.531 seconds. The main engines and crew cabin are also identifiable. After 10 seconds, the crew cabin was seen again with the front end and top of the cabin visible. As the subject moved further away and dropped lower on the horizon, the quality of the image for visual analysis deteriorated rapidly. Long-range tracking cameras followed the SRBs through range safety destruct. At approximately 75.8 seconds, the right SRB was seen exiting the cloud. Camera E207 shows the right SRB after the breakup, and the joints are clearly visible except for the aft field joint. This confirmed the location of the plume along the longitudinal axis of the SRB. The separated nose cap and deployed drogue parachute are identified at approximately 76.4 seconds. The shock wave from the detonation of the linear-shaped charge on the right SRB can be seen clearly. Simultaneously, the left SRB was destroyed. At approximately 37 seconds, Challenger had encountered the first of several expected high-altitude wind shear conditions, which lasted until about 64 seconds. These wind shears are best illustrated by the effect on the booster exhaust trails. The effect of wind shear was immediately sensed and countered by the guidance, navigation, and control system. Wind reconstructions were aided by comparing predicted exhaust trail shapes with acquired photography. The reconstructed winds were used in trajectory and flight loads analyses, which verified that the loads were within limits. Several flashes in the SSNE plumes were observed during the flight. As similar flashes have been seen on several previous flights, they are considered not to have contributed to the accident. The visible condensation that appears in this frame is created by shock waves which develop as the vehicle passes through the speed of sound. A large-scale search effort was initiated to recover the space shuttle debris. 22 ships, 6 underwater search vessels, and 33 aircraft participated in the operation. The pieces recovered initially were those found floating on the surface. The submarine fleet was used to locate and inspect underwater debris. Objects identified as being important to the investigation were retrieved. % of the entire vehicle was recovered in the effort. The ocean search area was located at the edge of the Gulf Stream at depths up to 1,200 feet. Approximately 93,000 square miles of ocean were searched. The recovered hardware was brought to the logistics facility, where reconstruction efforts helped to verify the investigation team's findings, as well as to analyze the structural breakup mechanics of the orbiter, ET, and SRBs. Inside the logistics facility, parts were arranged on the floor according to their location on the vehicle. "45% of the orbiter itself was recovered. The debris confirmed that the orbiter and its payloads did not contribute to the cause of the accident, and that the orbiter breakup was a result of aerodynamic effects rather than explosive effects. Shown here are parts of the orbiter forward fuselage structure, which surrounds the crew cabin. Extensive heating and erosion was detected on the right aft section of the orbiter. The paint was scorched and blackened on the right side of the aft fuselage. Thermal distress was apparent on the right rudder speed brake, while the left showed little effect. Thermal effects were also seen on the elevon. The aft left side of the orbiter showed no apparent sign of heat damage. The remaining recovered parts of the orbiter showed no evidence of fire or explosion from within the vehicle. All three main engines were recovered and helped to verify that they did not contribute to the cause of the accident. The external tank was similarly reconstructed. 25% of the liquid hydrogen tank, 80% of the inner tank, and 5% of the liquid oxygen tank was recovered. Most of the external hardware was also recovered. The nose cap sustained very little damage. In general, the recovered pieces were quite large. The spray-on foam insulation exhibited varying degrees of thermal effects from extreme charring to practically no effect. The external tank range safety destruct explosive charges housed in this cable tray were recovered undetonated, eliminating them as a possible factor in external tank breakup. The intertank region showed signs of buckling in the fore and aft direction. This would be consistent with the impulsive thrust that resulted from the sudden loss of liquid hydrogen from the aft section of the tank. This shearing failure of the forward attachment fitting with the right SRB was caused by the booster's rotation after the aft strut area failed. The stiffener stringers on the right-hand side of the inner tank show evidence of contact which match marks on the forward assembly of the right SRB. A section of the ring frame and a section of the aft dome from the lower strut attachment area was recovered in one piece. The lower strut attachment fitting had been pulled away. The effects of the anomalous SRB plume can be seen on the external tank, excluding an area which was shielded by the strut and attachment fitting. Approximately 50% of solid rocket booster hardware was recovered. An ordnance storage facility was used to house the motor case pieces, as some contained unburned propellant. Marks seen on the right SRB frustrum match the contact area shown previously on the ET intertank stringers. The size and location of the burn-through as indicated by the recovered SRB debris were illustrated on an assembled booster. The aft center section of the joint shows a large hole centered at the 307-degree circumferential position. The irregular hole is roughly rectangular and is about 27 by 15 inches. The steel case material showed evidence of hot gas erosion caused by combustion products flowing through the opening. The aft section of the right SRB showed a hole approximately 33 by 21 inches. The burn surface extended into the aft attached strut region. The exterior surface of the aft case featured a large heat-affected area. The shape and location of this heat spot indicates an impingement from the escaping gases. There was a small burn-through in the case wall which appeared to have penetrated from the outside in. This was due to the impingement of hot gases from the anomalous plume. The hole in the solid rocket booster segments was the result of the joint leakage on the right-hand SRB, which was determined to be the cause of the accident. The Presidential Commission concluded that the cause of the Challenger accident was the failure of the pressure seal in the aft field joint of the right solid rocket motor. The failure was due to a faulty design, rendering the seal unacceptably sensitive to a number of factors. Those factors include the effects of temperature, physical dimensions, the character of materials, the effects of reuse and processing, and the reaction of the joint to dynamic loading. More detailed analyses are contained in Volume 3 of the Report of the Presidential Commission on the Space Shuttle Challenger accident.